In this video, we are discussing solid mensuration and we are focusing on the cone. So we can see the cone and we'll be looking at the measurements like the surface area, the total surface area of the cone. So this, first of all these measurements we wrote out, this is the radius of the base, the circle at the base. This is the height of the cone. And then this L is the slant height of the cone. So surface area, when we talk about surface area, we can see these parts that make up this triangular side and the circle at the base of the cone. So the surface area is going to be the area of the slant, that is area of the curved surface, and the area of the base, which is a circle. So area of curved surface plus area of the base, circular base. So area of this curved surface is pi r L. So that is pi times the base radius times the slant height. Then the base is a circle, of course, and area of a circle is pi r squared. So when we factorize this formula, we have that the total surface area of a cone is pi r L plus r in total. So for volume of cones, the volume of a cone is equal to 1/3 pi r squared h. So using the height. Now we are going to solve some examples to show us how to use these formulas and other combinations we'll find out. We've been asked to calculate the curved surface area of a cone of radius 7 cm and slant height of 2.5 cm. So we write out the parameters that radius is 7 cm and slant height 2.5 cm. So here we've been asked to calculate just the curved surface area, not the total surface area. So for curved surface area, we have that it is pi r L. That's the formula for its area. So we have it as 22/7 times r, which is 7, times L, which is 2.5 cm. We divide, and then 22 times 2.5 is equal to 55. Since it is area, it is in, and this is cm, so cm squared. So we can see that here we are asked to find the volume and total surface area of a cone with circular base, diameter 10 cm and height 12 cm. Now we are going to write out the parameters that we need. We have the base diameter is 10 cm, and you know we use radius, so radius is half of the diameter, so radius is 5 cm. And height, now slant height isn't mentioned, so this height is just that vertical height h, which is 12 cm. So these are the parameters. Now we've been asked to find its volume first before we find its total surface area. So we have that the volume of a cone is 1/3 of pi r squared, the circle times the height. Okay, so we are set on that, and we are to leave our answers in terms of pi. I forgot to add that to the question. We have 1/3 times pi times r, which is 5 times 5 times height, which is 12. 3 can go into 12. We have 4. 4 times 5 is 20. 20 times 5 is 100. And remember, we left our answers in terms of pi. So 100 pi, since it is volume, is cm cubed. So 100 pi cm cubed, that is the volume. Now the total surface area. For that, we have the total surface area of a cone is pi r plus L. Okay, so in this case, we see that we don't have L as a statement given to us. So all we are going to do is we are going to draw this in perspective. So I'm going to draw this cone. And then this is of course the base. And this is the height. This is R. This is height. So if we look at this point, we can see that this is a triangle. Let me draw that triangle separately. So this is R, this is H, and this is L, right? And so we have that L is equal to the square root of H squared plus R squared, because L is the hypotenuse of the triangle. So this question is important in case you have a case like this that you don't have the slant height. You can always find the slant height from the height. You can always find the height from the slant height and base radius. Okay, so we are going to solve for L and then come back to this formula. We now have that the slant height is equal to H is 12, 12 squared, R is 5. So we have 144 plus 25, and that's giving us 169, which is equal to 13. The square root of 169 is 13. So we have that the slant height is 13 cm. Then we come back to the equation. So we substitute. We are leaving our answers in terms of pi. R is 5, and then 5 plus 13. 5 plus 13 being 18. Then 18 times 5, which is equal to 90. And we are leaving it in terms of pi. 90 pi, and it is area, so it is in cm squared. So here we have it. The base radius of a circular cone of height 4 cm is 3 cm. Find the vertical angle to the nearest degree. Now we are going to have it pictorially so that we understand what we have been asked to find. So this is the cone. The base radius. Okay, the base radius of a circular cone of height. So height is 4 cm and base radius is 3 cm. Of height 4 cm. So we have 4 here, and then the base radius is 3 cm. Okay. Find the vertical angle to the nearest degree. Now when we talk about vertical angle of a cone, we are talking about this angle here. And when we look at this part of this cone, we can see that we can draw a triangle. Let me draw that triangle of this part. So this is 3, this is 4. So this angle here is half the vertical angle, semi-vertical angle. So when we find this angle here, we multiply it by 2 to find the vertical angle of this cone. Is understood, right? Okay. So we have the opposite of the angle, we have the adjacent of the angle. So we are using tan, that is TOA. So tan theta is equal to opposite 3 over adjacent, which is 4. So we are going to say the tan inverse of 3 over 4. Tan inverse of 3 over 4 is equal to the angle we require. So tan inverse of 3 over 4 is 36 point something, and then when we multiply by 2, since we said when we find this, or let me just say 37 to the nearest degree. Then when we multiply by 2 to now find out the total, the vertical angle is equal to 2 times 37 degrees, which is 74 degrees, to the nearest degrees, of course. Okay. A cone is formed by bending a sector of a circle having an angle of 210 degrees. Find the radius of the base of the cone if the diameter of the circle is 12 cm. So, we're going to show pictorially the sector of the circle first. So, if this was the sector of the circle, for example, let's say that this is the 210 degrees. So this is the sector of the circle. When we fold it, we now find that cone. So we understand this part. A cone is formed by the sector of a circle having an angle of 210 degrees. So this is a major sector of that circle. Find the radius of the base of the cone if the diameter of the circle is 12 cm. So when we fold this, when we wrap it up together this way and form that cone we are looking for, so we form a cone. And then what we are now looking for is the base radius of this cone formed by it. And the diameter of this circle is 12 cm. Therefore, R is equal to 6 cm. That is half of the diameter, right? Good. So, for this particular case, we can see that when we fold this, that this diameter becomes the slant height. The radius of this sector that forms this cone becomes the slant height of the cone at the end of the day. And the circumference, that is the length of this arc, becomes the circumference of this base, because when we fold it this way, this arc now forms the circumference of the base. So those are the two things we are going to relate. We are going to say the length of the arc of a sector of a circle is, of course, the angle subtended by that sector over the 360 times the circumference of a circle, 2 pi r. And we equate it to circumference, and then the arrow we are going to be using here, let's use big R to represent the radius of the circle, and then small letter r to represent the radius of the base of the cone. So it's equal to the circumference of this base, so 2 pi r. You understand it, right? Good. So let us, 2 pi will cancel out 2 pi at the end of the day. So radius of the base radius of the cone is equal to pi theta over 360 degrees times r, where r is the radius of the circle, of the sector of the circle that formed this cone. So we have we have gotten the formula for it. So we are now going to substitute. Now we have that theta is equal to 210 degrees. That's the angle subtended by the sector of the circle. And then we have that the radius of that circle is 6 cm. So we substitute. We have that the radius of the cone, radius of the base of the cone, is equal to 210 over 360 times r, that is 6. 6 into itself is 1, 6 into this is 6, and then 3 into this is 7, 3 into this is 2, so 7 over 2. And 7 over 2 is equal to 3.5 cm. So that is it. Always remember this formula, that's the relationship between the sector of the circle that forms a cone and the radius, that's the base of that cone.